Integration, as you recall, is also often interpreted as an accumulation function. Now, for our functions, what we've been doing is we start with some known pre-calc formula, like the area of a rectangle. So we draw our curves. Draw our curves. All right, this is f of x, and this is gx. And you draw a representative rectangle. So this is delta x, and this is your height. And so the area of a rectangle is height times width, or h times delta x. And that's when we come into the area of this, the differential area of our little representative rectangle, that's f minus g of x times delta x. And then we take the limit as delta x goes to 0, we do our sums, and we get the definite area is the integral from a to b of f of x minus g of x dx. Now we can think of areas as an accumulation function in that we're accumulating rectangles. So if I wanted to find an area, and in this case from negative 2 of 4 minus x squared, well that's just 0 by the definition. But as we inch across, as we take this slider and move it across, we can see we are accumulating area underneath our curve. Now the only thing I want to point out here is areas between curves are positive as long as you're going from left to right. However, if I were to start this anywhere except negative 2, say I were to start my accumulation function at x equals 0. All right? So if I were to define it so that we start at x equals 0, and then if I were to go backwards, then this area from 0 to negative 2 of 4 x squared dx, remember, this is going to equal negative the area from negative 2 to 0 of 4 minus x squared dx, or this will be negative 16 thirds. 16, that's a 13, sorry about that. So when we talk about using integration and describing it as an accumulation function, the key point here is you have to figure out where you're starting. And if you're going from left to right, that area will be positive. But if you're going from right to left, your area will be negative.